We can see the holes for the body shell and the subframe are misaligned. By correcting the geometry between the two panels and bolting them together, the result is significantly improved vehicle dynamics and handling. In all modern production cars, the engine, transmission, suspension and body shell are all mounted to the subframe. Bolting the subframe and body shell together makes for an incredibly stiff construction, but problems arise between the mating of the two structures. You can see in this cut model that the bolt is far too small for the hole in which it is supposed to fit, with significant room either side of the bolt. The reason why the holes are made so big is to speed up the production process when the car is being built at the factory. However, because of the size of the hole, the body shell and subframe are able to move even when the bolt is in place. Looking at the pickup points from the subframe to the body shell, you can see the marks as evidence that the two panels are significantly misaligned. Further evidence shows that when the subframe is taken off, you can see the bolt is tightened with the hole offset, thus making it impossible to have an accurate geometry setup. Here we have a transmission casing on the left and subframe on the right, both marked with engineer's die. You can see the two faces are not seating properly due to the uneven surface on the face of the two components. The metal used in the construction of the component is very hard, and if they do not sit even and flat, they work against each other, creating a spring effect, detrimental to the handling of the car. So, how do the rigid collars work? The rigid collars will wipe out spring effect by giving the mounting bolt an even surface to bite into. The collars are constructed using a special aluminium which is tapered, and when it is fitted and torqued up, the metal spreads to form an even surface and contact face for the panels to mount on, making the bolt hole a perfect fit. This is almost as strong as welding the components together as you would in a competition car, for example. The rigid collars act as a body reinforcement, and once fitted to the recommended key points where the subframe meets the chassis, the join between them will be perfect, significantly improving the handling of the car. Take a look at this example as the car comes over the step without the rigid collar. Notice the vertical movement in the body. Now look at the same car, this time fitted with rigid collars. The vertical movement has been reduced dramatically. Looking at the two tests side by side, the differences in the body movement are clear. The standard car at the top of your screen and the car fitted with rigid collars at the bottom. The rigid collar has removed any spring effect caused by the inaccurate join between the cross-member and chassis. Note how the suspension is far more stable, resulting in better all-round handling. Prior to the fitting of rigid collars, it was necessary for the driver to constantly correct the steering in a straight line. However, this is completely eliminated because the collar allows the vehicle's geometry to be set up accurately. Again, the result is vastly improved straight-line handling as well as a reduction in road noise. Another benefit is the improved feedback through the steering wheel, offering up a much more positive feel when changing direction at high or low speeds. Installation is easy and it's not necessary to remove the subframe completely. Simply create a 40mm gap between each mounting point and insert the collars one by one. With the right equipment, the job should take less than an hour. Handling, vibration, noise, there is no limiting factor. Rigid collars will only improve these areas. We are constantly developing more models, enjoying improved handling and more enjoyable driving.